probably will be the future of the identity and a new way to make a KYC and AML.
Sometimes they can do some abstraction, but these very particular implementations on EVVM is always abstracted natively.
One thing we try to create the equation is the gas fees.
So in the infra aspect, a traditional blockchain or L2 needs validators, nodes, DevOps, incentives. That is one of the most important parts of the blockchains. On the EVVM, zero. It's everything inherited from the host. No infrastructure is needed.
I think it's the app store for blockchains, basically.
Ethereum infrastructure by the offer and demand game that is paying gas, getting incentives, and be aligned is what is alive for decentralization, permissionless, and determinism. So for us, it's vertical scalability.
Ethereum is often referred to as public infrastructure. Imagine Ethereum as a city where we are going to use the governance, the police there, then roads and things like that to set up our business there. And today we are going to talk about a project which actually kind of gives us a picture about how this will come into reality if we are using Web3 and Ethereum as public infrastructure. Welcome back to Ecosystem Project Demo. This is episode 31. Today, I'm joined by 3 developers of project EVVM, Ethereum Virtual Virtual Machine, and we are going to learn about how this will look like in real world. Welcome, Kevin, Arman, and Arturo to Ecosystem Project Demo.
Thank you, Poha, for having us.
Well, we would love to hear about the project. I'm sure there are a lot to talk about, and I understand there is a presentation as well as demo. But before we get into the project details, it would be lovely to hear from all 3 of you about yourself, the way you entered the Web3 ecosystem, and how you joined together to come up with this project. So let's start with a brief introduction.
Okay, myself, I entered to the ecosystem of blockchain in 2009, checking the security of Bitcoin, the nodes, and the cryptography. Later on, I saw that was very secure and no possibilities to hack it as a protocol, as a consensus. So I continued with Ethereum after a few years in 2015 when I noticed about it and got information. I started checking something on smart contracts. And then I continue with my things on internet in general. And in 2022, I participated in an ETH Global Hackathon in Mexico, and that made me very passionate about solving problems on infra, on protocols, and the Ethereum itself. And from that moment, I didn't stop developing on Ethereum.
I'm Arturo. I've been somewhere in software development. I have been 12 years working on software engineering, design some solutions, and I started working on saving circles solution that after some researching, we find blockchain like Ethereum, and we start finding some features that we need for this technology to help people in LATAM mainly, making these saving circles in a decentralized way. And that I met the team, Germán in DevCon Colombia, and I met Jistro, I think like 2 or 3 hackathons after that. So we start work together. We presented the MVP of this in Waterloo, but we are going to give you more details.
So yeah, my name is Jistro, also known as Kevin. Well, I was in software development like formally 2 years, but I was getting knowledge from university. My path to Ethereum begins with a simple thesis using artificial intelligence just for track some packages. And after figuring out like, okay, that's good using artificial intelligence for that. But what if some data or some database gonna be corrupted? So I figured out why don't use Ethereum just for that. And after reading about Ethereum, checking about Ethereum, I literally fell in love with that and began my path. I met Germán like 3 years ago if I remember correctly, it was in a hackathon, and Arturo, I met him the same, like 3 years ago in hackathons. Literally, I meet both in the same hackathon.
I mean, this is the beauty of this ecosystem. We meet each other in different hackathons, events, and we come together and start building together. I met Herman for the first time in Argentina, though we know each other for quite some time. He had been an active EIP author, so I had an opportunity to interact with him online, but that was our first meeting there. And I think in this EIP summit that we organized back in Argentina, I introduced the entire group with saying that everything in Ethereum starts with what if. Like Jistro mentioned, that what if this happens? So I'm so happy to learn how you all came together, and I feel that this is inspirational for people to come together. We are going to different places and meeting new people. There could be new connection and there could be birth of some new project. So thank you all for joining us here today. And I understand there is a presentation, so without further ado, let's kick into the presentation.
Well, thank you for this invitation. We are very happy to be presenting EVVM to you and to all the audience and the Ethereum developers and community. EVVM is Ethereum Virtual Virtual Machines. It's virtual state blockchains for Ethereum looking for vertical scalability. So what can't be done on EVM today? This is very important. There is a typo there, sorry. Chain compliance means that the whole chain, Ethereum itself, Base, Arbitrum, other EVMs can be compliant as a whole, right? Every chain has their own compliance and it's fine for different services. In example, Circle is compliant with the USDC in their way, so they can do blacklisting and they can freeze some accounts, USDT as well, but the whole chain itself is not compliant. What we can do with the EVVM that we will look later is that we can make a part of the chain compliance. Token incompatibilities. An example, X402, that to be used by any service, it has to be wrapped or it has to be a token launched respecting some EIP that supports a paymaster and a few other functionalities. Complex privacy solutions. We know that when we talk about privacy, there is a lot of signatures involved. There is a lot of different protocols that we need to audit. And later, sadly, there is many drained protocols and treasuries. Post-quantum resistance that now is becoming a thing after the CK concerns. Now we are talking about quantum resistance on the signatures. Gas and account abstraction is also a thing that continue without a global solution. And the multi-chain composability that is a everyday problem that we are facing. Why I'm listing these points? Because EVVM solves all of them. So EVVM solves all of these problems, and we feel that is also the future for stablecoins and agents. That is the topic for this 2026. What brings EVVM? In the EVVM, that the solution is basically smart contracts that are deployed within a blockchain, emulating all the functionality and having a virtual RPC on the core contract. This means that the transactions goes into the chain directly or through a relayer that is an external owned account, and the payload inside the transactions is the EVVM transaction. So there is where the abstraction starts. This means that everything that is executed on a private environment, a virtual state blockchain, is carried to this deployment in a transaction itself. In this moment, the user doesn't need a gas because the gas is paid by the one that is relaying this transaction. That doesn't matter who is. Everything, all the magics will happen inside the EVVM. This is a gasless UX completely because now the accounts can sign transactions completely off-chain. They don't need to connect to an RPC and they can interact freely inside the EVVM. Doesn't matter if they are using CK, full homomorphic encryption, a normal transaction, registering a name, or even through the abstractor service, they can interact with the whole ecosystem doing composability. And there is where the full composability item comes here. This means that now, if you want to use the typical account abstraction, you can make the call as you usually do from an external owner account or through a sponsor. This is fine. Well, using the EVVM, you can also do it, but you don't need to configure it. You can do your own call. You can control your own account abstraction contract with your own signatures, but other person can bring the transaction to your EVVM, and the EVVM will do the rest of the execution. To be more clear on this and more targeted to devs, this means a full abstraction. So the whole blockchain is abstracted. So we have to forget completely about gas. Believe me now and check it later. But gas doesn't exist anymore if we use an EVVM. Secure privacy and full homomorphic encryption for confidentiality. Arturo will show later on this demo how we can add CK vaults to create services with full privacy for users to send tokens, receive them, split them in different transactions without revealing who are involved in these transactions. This could be a little controversial because these are the type of activities that are not very well seen by governments. But what happens if we do a KYC and AML to our EVVM? In example, a bank that wants to bring privacy for their users, but want to be public for the interbank experiences or for the funds to be used outside their scope. They can deploy an EVVM. This EVVM can be KYC'd, AML'd, or with EIP 8004. That is fun because I send the ERC 8003. So every time I see 8004, I remember that was one after. It's just a note in the middle, anecdotic. But well, imagine that we were a bank and today we want to bring our users on chain and we want to give them privacy and we want to offer products for the whole ecosystem as well as give our users to have the chance to use Aave, Uniswap, and any other deployed protocols. Well, we can deploy an EVVM. We give this opportunity to all our users from our institution. We can be compliant because all the addresses that are accepted to interact in our EVVM ecosystem are KYC'd. So we can have a CK vault inside. They can use CK vault. They can have a Tornado Cash inside the EVVM because this is legal. They are compliant. And to go outside, they can also do. So you can have these private environments in Ethereum that will be small parts of Ethereum, Base, Arbitrum, any other EVM that are compliant. And what happens outside the walls is configurable. And they will also have a native X402 because Paymaster and Async nonces are part natively for the EVVM structure itself and architecture. And for the post-quantum resistance, we had today a meeting with the Lucerne University in Switzerland. And we already have been talking with QUIP Network, that they are both on the post-quantum security research. And we agreed to start working in the quantum-resistant EVVM. And we have a plan. And thanks to the abstraction that EVVMs bring, we can start using with our name service that is upgradable and resolving on-chain, quantum resistant account ready to use in the smart contract level. So it's about execution level in 2 months or 3 months at most. This doesn't bring quantum resistant to the EVM itself because the nodes and part of the consensus is still using the old cryptography. But to operate on chain, users could be using an EVVM to interact within the whole ecosystem using their quantum resistant signatures. And this is very important because it's more secure that don't have it.
So in this part, well, as any blockchain, it's completely yours. So your rules, your environment. So you can configure how the interaction happens inside the EVVM. So if you want to a little bit closer or maybe a little bit open, or maybe some addresses can interact with this EVVM, you can do it completely. and you had compatibility with all the host protocols. So in comparison with some L2s or L1s that all the protocols need to be inside of these blockchains, and well, all the liquidity are depending on those interactions. With EVVM, you can choose any blockchain that you want. Maybe, I don't know, like Ethereum Mainnet or maybe Arbitrum, and get all the liquidity from this host blockchain to your virtual blockchain.
Here we have an example of the architecture that is the most desired from bank institutions, and in fact is a request. We have an agreement with a company that is called NTT Data from Japan, that they are supporting us in the way to find banking institutions to do implementations. They already gave a talk about EVVM in the Decentralized Trust event from Linux Foundation in New Jersey on January of this year about EVVM. And we deployed a Hyperledger Besu configuration with a consortium of EVVMs, bridging to Ethereum mainnet for offering their products and get, alias extract, liquidity to be operative on their private environment, and then throw it back with another product. So this is the standard implementation that it was proposed by Arturo. That basically is a bank that has a private communication with a trusted execution environment interface, and on that interface there is happening full homomorphic encryption communication that gives confidentiality to interact with the EVVM ecosystem for the users of the bank, and then the users from the blockchain in general can have a configurable access, as Kevin said before, to the EVVM to come and go. At same this happened with the CK vaults. The previous configuration I was talking is very, very similar. The only thing is that the proofs will be generated also in a trusted execution environment interface, and well, Arthur will show in the demo that is common.
Yes, so starting from understand that privacy is by layers, we are working with, let's say, two types of privacy, like confidentiality from fully homomorphic encryption and the probable computation with this selective disclosure data with CK proofs. So we are combining this. We also understand that we are combining these expensive systems, but we are trying to improve the efficiency. So we start to doing basically a vault. It's just like the normal vault that you already know. This vault is receiving deposits in tokens in ERC20s. We generate a proof to just prove that deposit was made in the vault. With ciphertext or fully homomorphic encryption, we are encrypted the amounts of these receipts, basically. Also, we are planning to improve the architecture, encrypted the rule of each deposit in the Merkle tree. So here we take this approach because Vitalik was mentioning some stuff about privacy and transparency, how this ability to make privacy was like necessary for users and optionally for enterprises, basically. So here is more about how we are using privacy for users. We also select fully homomorphic encryption because we find that it's more composable with other solutions, with other DeFi solutions that are already in the market, more than CK. So because we are not trying to redesign every protocol or everything on the chain, because also EVVM is composable with other protocols, we choose this way. But also we add a compliance layer that is basically doing a KYC and AML for institutions, because this is important. The proof is like Privacy Pulse is doing their own system to also try to make compliant stuff. So how it works. In the UX side, we abstract everything because EVVM has this ability to help us that it's more easy for the user using a CK applications with no need to understand like hard concepts. or heavy concepts also. So we have relayers that it's basically a fisher. We have our users. So the relayer lives in the EVVM, is connected, and the user sends transaction. The fisher or relayer takes this transaction. We are checking as a middleware the KYC part, the KYC layer. If the user passed this KYC or is valid for this AML stuff and compliance layer, we deposit in the CK vault to start to give him privacy, give him private transactions, private movements, private payments also for this feature that is splitting nodes basically. So also in the EVVM2 part, in the DeFi part, we are integrating with Uniswap and Aave in a private way, as I mentioned before, for fully homomorphic encryption. So we can do these encrypted amounts and encrypted movements. So a little bit deeper, if the user is not registered or is not passing the KYC, is basically a Boolean true or false. The KYC or the transaction, the interaction with our protocol in this version, in the CK version, is denied. In case that the KYC is passing, we generate a proof of the deposit, as I mentioned before. And when the user tries to make the withdrawal, we are checking the proofs. Also, we are checking the compliance layer, that is because today I cannot be on the OFAC list or on blacklisted or sanctioned countries, but tomorrow probably. So we are checking in every transaction that the user is trying to do this compliance layer to try to avoid breaking some regulations, some rules. The user tech that we are using is the KYC module for the EVVM. We are using Noir for generate the CK circuits with these verifiers that it's generated with ultra-prone and ultra-honk proving systems, and also fully homomorphic encryption that is not there, but we are also using it.
So right now we deploying EVVM for make the integration. So it's a simple process is using a CLI. So you can configure in literally minutes your own EVVM instance in every chain you want. So I'm gonna skip a little bit in the deployment part. And right now we had pre-configured our EVVM, and after this we had all verified contracts and we get our EVVM.
It's interesting to point that we have a CLI deployer and you can deploy your own EVVM in 1 minute, literally, with this tool. And it's very interesting, and it lets you choose which chain do you want to deploy on, and also verifies the contracts automatically for you.
So right now we are preparing the contracts for the CK integration. It's just a simple giant deploy and using our staking core and also our admin address. So we can deploy a CK vault in, again, literally minutes. Right now we are seeing the deployment, the compiling part, and I'm going to skip a little bit. So if you see right there is complete deployment. So after this, we use a simple example. One is a deposit into the pool. We generate our commitment. We confirm that all the signatures for that service, and immediately making a deposit for our CK vault. After this, if you have the commitment, you can make deposits, even split deposits, just for different contracts you want. So right now we're making a deposit, a split deposit. I'm gonna skip a little bit. And yeah, we made that split for various address. I'm gonna skip a little bit, and if you want, we can withdraw all the tokens for the vault using, again, these type of proofs.
Here is important to note that all the transactions, as you've seen, were abstracted because the UI was only asking for signatures, but never for a transaction on chain. And this is one of the capabilities that the EVVM brings to the whole ecosystem on the EVM. The transactions, the user doesn't need to transact anymore with the blockchains itself.
Exactly. The end user doesn't need to care about the gas fees, all the stuff. It's just completely abstracted. So they only need a simple signature is using RSC191 and send it out to any place. If you want maybe an API, maybe radio signals, or maybe just a simple message through Telegram, it can be possible. Any medium you can send message, you can think as a simple feature. There's we call the nodes to extract all the transactions. See, you can see it's all the withdrawing and all the deposits. So it's just simple and easy.
So why EVVM is cheaper? Why EVVM exists? So in the infra aspect, a traditional blockchain or L2 needs validators, nodes, DevOps, incentives. That is one of the most important part of the blockchains. On the EVVM, zero. It's everything inherited from the host. No infrastructure is needed. If you want to add some nodes to the sharding execution, to the virtual sequencers or other kind of configuration, it's good. It's up to you. And we bring a lot of extra value. But to have it is not needed at all. Deployment time, 3 to 12 months to have a testnet, to test all your configurations, your different nodes, etc. In EVVM, minutes, just one command, as Kevin showed. Initial cost for having a traditional blockchain L2, 500K to 2 million. This is very arbitrary, but it's very, very costly. And in EVM, only the customizations, because this is open source and is free to use. We have now a license that is free for personal and academic purposes and research purposes, not commercial, but we are going to open it because we see that is a way to make this grow widely adopted, and also the community will be very, very thankful if we do that, and we think is the way. At the end of the day, we are open source believers, and we were feeling bad to have this a commercial license. I don't know how to explain it, but now we will feel more comfortable with ourselves as well. The maintenance, there is a maintenance cost on any traditional blockchain and L2s, and on the EVVM will be only more customizations and changes. On the security side, a traditional blockchain L2 is constantly receiving audits, they're giving bounties continuously. And on EVVM, all this is inherited, and then you can do small audits on the way that you are adding more code, or you want to check if everything continues good. And the gas for users in traditional blockchains L2 is always required. Yes, sometimes they can do some abstraction, but these very particular implementations on EVVM is always abstracted natively. So here is a little of the progress. I think, Kevin, can you explain a little of what's happening and how this happened?
So yeah, right now we had EVVM deploys in +2 chains. So you can see, like in this example, like Base, Arbitrum, Monad, Mantle, Celo. We have EVVM 42. It is requiring the middleware for all AI agents. And we had a fee of confidence and accounting for Ethereum, a Gasless UI payments app for coded by agent IDs for payments. So you don't need to know about any address, just a username. We have a Hyperledger EVVM Besu private consortium for banks with treasury in Ethereum. So if you want to go send out liquidity from Ethereum, you can get it in a private instance. And we had Gasless on-chain governance for boarding too.
Do you want to show the demo for the X402, Kevin?
Yeah, I can show you. Okay, So I'm going back a little bit. So it's a simple front-end example. So to be more simple, right now we are connected to our wallet and we authorize the payment. So if you can see, I'm going to stop right there. So they need a requirement. So they use the 402 error and they want the certain amount, the amount of the token they want to use, and they want to send and the timeout. So if you can see, if we are an agent, we need to send this signature request to the user to say, okay, I need to approve that type payment to continue this transaction. Why we need this? So sometimes AI can be a little bit problematic, more in hallucinations part. So if you let an AI agent alone, maybe they're gonna send a lot of money because they say like, okay, that's good because I hallucinated that. So with EVVM, you have the more secure path to verify if this transaction is going to be correct or maybe it's a hallucination by an AI. So right now we are getting the payment required. As you can see, we get the status and all the inputs necessary to execute it using EVVM with X402. So I'm going to skip some parts. Or this. So after this, we authorize and we confirm the payment. And if it's done, I'm gonna send you a simple message for the payment action. If it was correct, obviously we're gonna show it like this. And if it's correct, we're gonna show an error for this. So an agent can be more beneficial to use this, and the user can be more beneficial because they had a more secure pathway to execute all the transactions.
Here is also very interesting because as you see, we didn't request again for gas to the users. And this means that agents neither has to have gas. So now you can have a paymaster that doesn't need to be registered because anyone can sponsor these transactions. So they can bill after it in a monthly basis, or there could be a wallet with gas specifically for all your agents set up. So you can sponsor this gas for all your agents without needing to do a configuration, because doesn't matter who is bringing your transactions on chain. If you want, you can restrict it. You can restrict in the EVVM the transactions by transaction origin, that is who is submitting the transaction to the blockchain, the first one in the chain of events to submit, or you can also restrict it to message sender, that is the last one. This means that you can also restrict the transactions to be executed on chain by a specific contract. And this is very good for DeFi. In the DeFi example, when we want to have an order, a limit order, we have to do a staking, or we have to authorize a third-party contract to access to our tokens. If we do a staking, we are freezing our money. If we are authorizing a third-party contract to use our tokens, we are in a potential rabbit hole of security that will end on our loss of tokens. With EVVM, we can pre-sign a transaction of our limit order to be executed as it is, and sign in the message sender field the address of the contract that is going to execute it, that is the DeFi contract. So this contract, that is something very interesting, can store on chain our transaction because no one can execute it. Using asynchronic nonces, it will not also cause any damage to our journey on the blockchain, because we put an asynchronic nonce that we are not going to use except for this. We put the message sender, the contract that is doing the DeFi, and then this transaction will be stored on chain by the contract, and only a trigger will execute it by the contract because nobody else can execute it, because we'll get reverted by the core contract of the EVVM, because we will not match the message sender to the contract. And if this happens correctly, the contract will be able to execute it. Of course, the contract will have to check if we have funds first to avoid a revert and make a transaction that will be not worthy for the incentives that has for the one that is executing this to activate it on chain. But the nice part is that we didn't have to authorize the use of any token, and we didn't have to stake anything. And this opens the possibility to many, many, many other use cases. The possibility to give contracts our transactions, not off-chain actors, on-chain actors, is something that is not possible in other way on Ethereum today without staking or without failing in risk of authorizing our token splits. And then to finish our presentation, for this 2026, we think that the ecosystem is Ethereum and stablecoins and agents are ready to ship. I don't know, Kevin, if you want to explain a little more of our suite of solutions that EVVM has.
Yeah. So right now, I say Herman, the ecosystem of Ethereum are stablecoins, are agents ready to ship. So we have a pretty good suite for all stablecoins and agents needed. So you can integrate with EVVM, make your own EVVM just for agents. Maybe you want to make a simple closed ecosystem for your own agents, or maybe like a mold book. For example, instead of have your own Facebook for your agents, you can have your own blockchain for your agents. We have yield generation. So any stake doing inside the EVVM can generate yield. This is good for stablecoins or even banks. They want to make more improvements about the yield generations. And you can generate your own sandbox. So you can use EIPs and begin to test it out inside the EVVM to see how it's going to be. And if you want to implement another EIP, it's just simple as point out of the contract and that's it. And we had a QR EVVM. So for banks or even stablecoins, it's a very way to execute.
We have also ready for having for the developers Scaffold-EVVM. We have the CLI deployer. We have a boilerplate that is ready. We have a coffee EVVM is called, that is a full example of a deployment of a store using EVVM for payments. And also the X402 implementation is complete and is ready. And the CK EVVM implementation is also ready in the repo for Clonit. The CLI deployer, of course. So there is also a EVVM GS library that is TypeScripted, so it's very interesting for any developer to do a feature, a relayer, or an implementation on apps or their own contracts. Also examples on how to create a service. Service are the other contracts that interacts in among the EVVM ecosystem. And there is a full tokenomics plant inside that you can activate it, and it's using reward for the features and the actors that are helping on the execution of these transactions, that they should be doing staking. So it's a compromise also to the layer, and they will get the yield generated by the treasury where all the tokens are deposited to use inside. It's a little complex. It's a whole ecosystem. So for a call, it's difficult to explain everything, and I hope it's clear for the audience and the people that is hearing us. But we are always open to talk more about this, to do more chapters, and to also talk in another podcast or spaces that we get invited, and also we can have calls for clarifying everything. So thank you, Poja, for this opportunity. I would like to know if you have more questions for us, and if you want to resume this conversation in outside the presentation, please let us know, and thank you.
Thank you, you all. Of course, there was a lot to take in, and I can definitely see room for having another version of it, like another episode of this particular project. There's a lot of ingredient of a successful ecosystem. You talked about vertical scalability, you talked about X402, post-quantum resistance, and there is this account abstraction, the basic concept behind it. It's a lot of things going on, and I'm hoping that it will be really good project. Curious if it is already in mainnet, or are we still in the testnet phase?
Our contracts are ready to be deployed anywhere. but we are about to start. We were quoting right now the audits from very very known and formal auditors on the ecosystem prior to push or to incentivize devs to deploy this on public mainnets. So now the CLI offers you only to deploy on testnets for security reasons. We want to be responsible with this. We want to be committed with the security of Ethereum. So we are improving the security. We don't want to make it worse. So before making something that will be widely adopted, if in the best case, we need to guarantee the minimal commitment from our side, that is a formal audit. So after this formal audit, that we think we will happen and take end of process by July, maybe August, maybe early, who knows? We are going to promote it to be adopted for mainnet. But the product itself is ready. The code is just improving on services, improving on more things to make it ready.
So currently it is like under commercial license, as it was mentioned. It is not for people to open source and can be used by anyone else right now. I understand the limitation of being audited. It is always good to be audited because that gives a comfort to user and implementer, but just where we are at this status.
We are open source. We are free to use for personal and academic, but we are going to open it also for commercial use. Right now, the license that you can see when you see the code, because it's open source on GitHub in our repo, is a license for non-commercial use, but this will be extended. So you can trust us and start trying to do your developments on that. But the license will be updated this month.
Very well. Well, as we understand, there is a lot to take in. I want you to take a step back, maybe consider our listener is someone who has never used blockchain in real sense. They are the kind of end users of the product. Say if this is adopted by a bank, he or she may be the user of the bank. For them, if you have to explain EVVM in very simple terms and maybe like in a minute or so, it can be taken in by the individual.
I think I can explain is the app store for blockchains, basically.
The simplest way to say so. Thank you. Very well. That kind of explains a lot of things. As we started Ethereum as like world computer, smartphone, the reference as an app store is very good to have here. So I understand right now the project is using ZK to hide the data, the personal information, because KYC and AML is also there in place. Is that the way to meet the regulatory requirement as well as the actual benefit of blockchain technology?
Yes, I mean, we need to do more work around this, also because of the culture for some governments need to switch or need to be extended for understand the CK benefits, also for understand the CK complexity. But when we start working more together with governments or with institutions that make this accepted, because if now I'm going to a place trying to not showing my ID, trying to show my CK proof that I'm older than 18 or something like that, no one is accepting me, right? This kind of verification, it's valid computation, but it's not valid in terms of institutionality or confidentiality. But yeah, we need to work more around this, make more acceptable for institutions. Yes, probably will be the future of the identity and a new way to make a KYC and AML.
That's brilliant to know. Well, I understand the concept of EVVM is basically building your own virtual machine, building your own project altogether. So if there is a developer who would want to launch their project on top of EVVM or with the help of EVVM, I wonder how does building with EVVM is it different than building on top of any layer 1, layer 2 project, like something that is very unique? What is that we are removing from the equation that helps the builder to build on EVVM?
So the more easy way is that more of the protocols they try to develop, one thing they having for sure always is like, okay, the user needs to pay gas. But if we want to be more open and want to be more usable, one thing we try to create the equation is the gas fees. So with EVVM, you can abstract directly all the stuff for the end user, so they had to worry about the gas fees. And develop inside the EVVM it's more easily than just install a library, or if you want to deploy your own EVVM, it's just using a simple CLI, or maybe if you want to go more deeper, you can use a Docker container for all your needs. So it's more easy, and you have all the benefits of gas abstraction and all the abstraction for all your blockchains.
Oh yes, I forgot. We also have a Docker ready to use with an EVVM.
It's good to know. Well, yes, of course. Gas is one of the blocker. I imagine when an institution wants to bring a blockchain into mainnet adoption, gas is one worry that everybody is worried about, especially when compared to Ethereum. Paying in Ethereum is like high. Also, I understand this project talks about cross-chain payment of gas, and everything is being done with a concept called Fisher. I'm curious if you could maybe explain a little bit about Fisher. Who can be? Do they require some special equipment, or is it anyone having a laptop can be Fisher for this protocol?
The concept of feature comes because we started when people were thinking in how we are going to tell people that exists more than one blockchain that is Ethereum. How difficult it is to switch from Ethereum to Polygon. We come from that era. So for us, it's very fun, but at the same time, is like relieving. But that every problem that we have faced in blockchain about UX wasn't a thing later. We discovered that there was a solution, or maybe it wasn't a problem, up to the gas. The gas is the first blocker that we really found a little blocker. So the Fisher was a network of incentives where anyone can fish a transaction in a fishing spot, is what we called. So the fishing spots were Telegram groups, the mempool of Ethereum mainnet, maybe a radio frequency, an API, where different actors, relayers, can go to try to catch transactions, to fish transactions, and deploy them on the EVVM, getting a reward. This is where the Fisher's figure comes into the game. Later, we found that the Fishers are not only incentivized by getting rewards, they can be incentivized by being a business that wants to sponsor all their user transactions, or just I deploy this contract that is a DeFi contract, and I promise you that if you throw your transactions over there, I will go and execute it because I have benefits for you using my service. So my contracts like Uniswap. Now Uniswap, if they want to say, we will sponsor all our users' transactions, they can give a payback. It's okay, but this is not sponsoring. If they were deploying using an EVVM, or if they were using an EVVM, in fact, we have Uniswap implemented. The API of Uniswap are implemented in the EVVM for quotings, in this case, for other concerns, but we have also a peer-to-peer swap that later can be Uniswap before on EVVM without any problem. But if they would like to do that, they can do tomorrow if they were on an EVVM, because they can say, we will sponsor all the transactions, the valid transaction that has as a target our contract. And they will just need to go and execute it. So features are important. Is relayers the most understandable word, because our keys interconnecting the non-gas abstracted word to the on-chain gas necessary word. So is the one connecting the transactions of the EVVMs that are like intent at the end of the day, unless are on-chain, and the interface of the contract that are the virtual RPC we were talking on the first time.
I'm sure this is very helpful for non-technical users when they don't have to worry much about like how to pay the fees for every button you click over there. So definitely this concept will give ease to many users and will help increase adoption. Well, let's say an enterprise deploys EVVM today and they are built on top of it. They are in production and then the protocol evolves. what does an upgrade or migration look like for them? Is there a smooth path forward, or they would be locked in the older version?
There is a few ways to do this, like upgrade or migration. For first, what we imagined is that maybe you don't need to do a hard migration. So what you do is there is a functionality on the EVVM. All the proxies or delegate calls or contracts that are interconnected on EVVM has the possibility to get renounced. These functions can be renounced, so you can't change it anymore, got frozen on chain, or you can still have the possibility to update them. When you can update, there is a time lock that you also configure in how will be used. Time lock means you have to tell the users 30 days, 40 days, 1 week prior the change, what are you changing? And after this time, you can apply the change. This is important because it's a security measure that if you are doing something that the users don't want, but you want to keep all your contracts upgradable, well, you will have to do a fair usage of these functionalities. And there is one that is the fallback contract. Before the fallback is activated in the EVVM core, there is a delegate call that is null by default. But if you want, you can create there a delegate call to catch everything that is going to be executed and make this call. And this is how you can make upgrades to the core EVVM code itself. Later on, you are always able to freeze. Also, if you don't block it, your EVVM withdraws and certain activities, so you can tell the users, hey, we migrated to this other EVVM, and you create a service that is a contract that is connected to your EVVM and the second EVVM that you are now deploying as the upgrade, where this service will be migrating the accounts that activates the migration, the necessary migration to the new contract. So this will be like bring one NFT to another contract by burning it and reminting in the second contract. It's not very complicated, but it has to be done properly. Migration is not a thing. It's just migrating the balances and tokens and amounts from one contract to another. Or you can do also with the upgrade that maybe you don't want to migrate everything. You want to just apply some upgrades. You can do it using the given functionality.
So a lot has been already considered in this project, and I now understand like going careful about it, because it may involve a lot of fun, lot of money in there. Just imagine that EVVM succeeds beyond your wildest expectation. What does the world look like to you?
Hyperstructures where the people can contribute and where something else is needed and is not given. A hard fork of an EVVM is happening while we sustain the Ethereum infrastructure by the offer and demand game that is paying gas, getting incentives, and be aligned is what is alive for decentralization, permissionless, and determinism. So for us, it's vertical scalability. We imagine one chain, maybe it will be more, but we imagine just one chain with a lot of virtual blockchains there, scaling using the resources of Ethereum, not only properly at 99.5% of demand that is needed for a healthy ecosystem. A chain that is not being used or is on the lowest demand is not on the full performance.
A beautiful world out there. All right, so we are at a good section to move on to our next round. But before we go there, I would like to mention our community partner, ETH Clutch. I understand Herman is also a very good friend of Simona, so he already knows about ETH Clutch. So ETH Clutch is organizing its annual event in the month of May, and ECH is a community partner to that event. Anyone from ECH community may reach out to us for free tickets or discounted tickets. We would be happy to provide links and resources that they are sharing. So yeah, if you are planning to join the event in person, please reach out to us. And if you are someone who is trying to organize an event at your local community, reach out to us and we would be happy to partner and support. Moving on to the next section. Right. Well, I have few last questions. Any one of you can maybe go ahead and answer that. We would like to have some precise answer for following question. We generally call it as a rapid fire round. So if you're ready, we can get into it. All right. One feature in EVVM that you are most proud of, but almost no one talks about it yet.
A little bit hard, but I will say in the CK-EVVM, I love the part of the privacy feature.
One blockchain project you wish existed, but nobody has built it yet. It could be on EVVM.
Well, if I want, maybe a bank system, a decentralized bank system.
An EIP or protocol improvement you think is underrated and deserve more attention.
This was a good one. Arthur, Kevin, come on.
Okay, I think ERC 4337, that it's a construction. I think we use have the starting part, like the community is not exploring more, like more use cases, more experimental stuff. I think we try to make more deep in that ERC.
What's the first EVVM service you want someone to build on?
Yeah, it's pretty difficult because there are many ideas, but the one thing I wish for sure is like typical payment systems, because we see all the payment processes, like, okay, if you want to pay with USDC, USDT, all the stable coins, if you want to pay with this, you need forcibly to have gas. So on top of you pay for your coffee, your packages on Amazon, etc., you need to add the gas fee for that. So if we eliminate this part of the equation, it would be more and more easy to integrate. So I think it's the best service anyone can build.
I will answer also. I would really want to see games running on top of an EVVM, but high consumption transactions games, because with async nonces, we have the potential similar functionality that we have with the UDP protocol on TCP/IP. And UDP means I will send you a lot of information and you just need to catch most of them to follow some game timeline, right? With EVVM, you can also do the same with asynchronic transactions, sending to a very, very not reliable, high efficiency network, and the transactions that come will start doing the checkpoints of how the game will be evolving. So a first person shooter or something that needs a sports game on chain, using this for me will be great, because the sequencing of the transactions will not affect you, because are not sequential nonces, are not more 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now are assorted, they are asynchronic, and the ones that came put you on the game. So we will bring the concept of lag on chain, and will be a good news, because means that we are now using blockchain also as a source of truth for games that are live games that should be like playing very fast without taking care of one transaction that get blocks, and then you are out of the game.
Game has always been like one of the primitive use cases for blockchain. So this seems to be a perfect one for this particular project. Yes. Well, my final question is, I think it is applicable for all three of you. So maybe all three of you can respond to this. If you couldn't work in crypto, what would you be building?
I can answer this. So I always be a open source guy. Instead, if I build in crypto, I was collaborating in some open source project. And even so, like all the crypto protocols and all the crypto products are open source. So it's like working in the same environment.
Automotive something like automotive systems, or fixing parts or something like that.
I will be a chef.
Interesting. Yeah. Again, I would repeat my statement that this is the beauty of Web3 ecosystem. People come from different background, different interests, and yet they are together to build something which is good for the entire ecosystem. Well, this was great conversation. Where can our people find you if someone wants to contribute to the project, want to learn more about their progress? What is the best place to go to?
If you are a builder or want to contribute with the project, you can find us on evvm.info. You can have all the documentation and all the information, even the GitHub repo, so you can check it out. And if you want to contribute for the contracts, we have all the documentation for how to contribute.
And if you want to join our Telegram community, the channel name is EVVM.org, and you can find it on Telegram. And on X, we are Rolamate. I think this will be written in the post or somewhere. Yes, you are welcome to join the community in any way, contributing in the GitHub, asking questions or writing some documents. And anyone that wants to invite us to their programs and to talk to the spaces, we are very open to talk. Also, we go to many conferences to talk about EVVM and virtual blockchains as well. And we just came from ECC. We were talking there about virtual blockchains. Well, we are very hungry to build. So we want to continue doing this. And that's why we are open sourcing and free licensing this, because Kevin said we are open source guys.
Very well. Well, if I may request you to maybe send the links to all the presentation documents and other resources that you have mentioned right over here, we would love to include them all in our show notes for people who are following these podcasts. And yes, of course, this was a great conversation, genuinely one of the interesting infrastructure project that we have discussed in this podcast. I believe that it is going to solve a lot of real friction that most people just accept that as a part of crypto. And I would like to wish best of luck to the entire team. Hopefully we see the project on Mainnet. I guess the timeline mentioned was July and August. So yeah, all the best to the team. Thank you all for joining us here today.
Thank you for having us.
Thank you.
Thank you.
EVVM is not a project, it's an effort to make an entire ecosystem. I wish all the best to the team. Dear listeners, if you find this project as well as this series interesting, please share it with like-minded people. Check out the show notes for details of this project, and we will try to bring more and more informative project, the public good project, for your references. Stay tuned. Cheers, everyone.